Okay, hello everyone, and welcome. Today we're going to look at conditional probability, the second part. Okay, so we're going to be looking at these tree diagrams here today. Remember earlier we looked at contingency tables or frequency tables. All right, now we're going to look at the tree diagrams. Okay, just a quick review. Guys, independent events. Again, it means that one event is not affected by the other. Like tossing a coin. All right? One coin toss doesn't affect the second coin toss. Just you flip it again. Those are independent events. The outcome of one event does not affect the other. But events can be dependent. Again, which means that one event does affect the probability of the second one happening. As an example, we looked at this before, marbles in a bag. All right, what are the chances of getting a blue marble? Well, it's 2 out of 5. But after taking one out, now what are the chances of the second selection being a blue marble? Well, it depends on what happened in the first selection. If you picked a red one or a blue one, it changes the odds of picking a blue one the second time. It might be 2 out of 4, or it might be 1 out of 4, depending on if the first selection was a red or blue. Guys, this is because we're removing marbles from the bag. So the next event does depend on the previous one. All right, replacement. If we replaced it, we would have independent events. With replacement, you have independent events. The probabilities don't change. But without replacement, I'm going to pick one and keep it out, and then pick another and keep it out. Those events become dependent. The probability will change the second time, okay? It will be dependent on what happens the first time. Now we can make a tree diagram. It's a great way to picture what's going on here. So let's look at our marble example. Again, the first selection, what's the chance of getting a blue marble? Well, it's 2 out of 5, which means 3 out of 5 that it's not blue, it's red. Okay, then we do the second selection. If the first one was blue, then the second selection, the probability it's blue is 1 out of 4. So the probability it's not blue is 3 out of 4. But if the first selection was a red marble, right, the probability of getting a blue marble the second time is 2 out of 4, 50-50. All right, and the probability that you don't get a blue one, which means you pick a red one, is also 2 out of 4, 50-50. Okay? The odds of the second selection are affected by the first selection, of course. Okay, now we can answer questions like this. What are the chances of drawing 2 blue marbles? What's the probability we get 2 blue marbles? Well, what you do is you look at the tree diagram and you follow the selections, both of them being blue. And you multiply those 2 probabilities together. Those are 2 dependent events. They both have to happen. So you multiply them together. 2/5 times 1/4, like they do right here. We end up with 2 over 20, or 1/10. All right, 1 out of 10. That's the probability that both marbles are going to be blue. All right, guys, now we can come up with the formula based on our example. All right, we're going to use notation. We talked about this earlier. All right, the notation is right down here. The probability given the probability that event B happens given that event A has already happened. All right, well, we talked about this already, kind of the notation of how we write that, okay? It's called conditional probability, and the probability that B happens given that A has already happened. All right, so again, in our case, The probability of the first selection being blue is 2/5. The second selection is 1/4. So the probability, these two multiplied together, is 1/10. All right, so the probability that they both happen is 1/10. And how do we get that? We took the probability of A happening times the conditional probability. The probability of B happening given that A happened. Okay, that's what we did right here. We took these two numbers, multiplied them together to get the probability that they both happened. So this second probability right here, the second stem on the tree, you might say, that's the conditional probability right there. All right, so we want to solve for this. We want to solve for the conditional probability to get the formula. I mean, here's the formula. You can use that one right there. But we want to solve this for conditional. Again, just divide both sides by the probability of A. All right, so probability of A comes down here. So here's our formula. The probability of B happening, given that A already happened, and we talked about this yesterday, is equal to the probability that they both happened divided by the probability that A happened, the first one happened, okay? That's where the formula comes from. Guys, as an example again, if 70% of your friends like chocolate and 35% they like chocolate and strawberry, the question is, what percent of those who like chocolate also like strawberry? Given the fact they already like chocolate, how many of those like strawberry? All right, which is what this is right here, the probability that strawberry happens given that chocolate already happened. That's equal to the probability that they both happened divided by the probability of chocolate. All right, which is what they gave you right here. It's 0.35 divided by 0.7. Guys, when you do this, don't use percentages. Use the decimals. Use the decimals when you're calculating this, okay? We end up with 50%. Again, that's 50% of your friends who already like chocolate also like strawberry. Okay, we'll do some more examples. That's the first time you've seen it. Again, here's tree diagrams. All right, guys, and that's it. Thanks.